Hi all, electrical engineer, Igor Ekimov, is with you. Today we will consider a laboratory power supply from the GVDA company for 30 volts and 10 amperes in a vertical design. Its maximum power is 300 W. Let's look at what it's for and how to use it. If you are interested in videos about electronic devices, then subscribe to the channel and press the bell. Special thanks for your likes and reposts. Such a device is needed by almost everyone involved in electrical and electronics. But those who are not associated with this can also find useful functions for themselves. What can this device do? 1. Conducting various experiments with electronics. Automation and low-voltage electrics. 2. Charging various batteries. According to the parameters of this device, it can even charge the battery from a car. 3. Use as a temporary power source for those devices whose power supplies have burned out. For example, you can replace a laptop's power supply until you find its original power supply. 4. Calibration of devices for voltage and current. I personally calibrated the clamp meter for DC current, but I'll tell you about this later. The accuracy of the power supply indicators is 0.5%. This device can be ordered in 3 versions according to electrical parameters. It is 30 volts 10A, like this device, 60 V 5A, and 120 volts 3A. And also in 2 versions of the case, vertical, like this one, and horizontal. I chose the vertical version, since it takes up minimal space on the desktop. For those who have racks for devices, perhaps the best solution would be a horizontal design. And in terms of electrical parameters, I chose a power supply with the maximum current, so that I could charge almost any batteries that I need. And I usually don't use a constant voltage of more than 30 volts. You can follow the link in the description and choose the appropriate option for yourself. What I like about this power supply is both its design and the features it has. This is probably the best DC power supply I've ever owned, and I really had a lot of them. The power supply comes in this packaging. Let's see what's inside. A seal made of foamed polyethylene. There is a special place for wires. So I took out the power supply. I draw your attention to the seals. Their rigidity is suitable. And there are special recesses for the controls. Here are the wires for it. Here is the network wire. The wire for connecting the load with crocodiles. At the bottom there are connectors to which you can connect the load in 3 ways. Using these pins, you can connect the wire by screwing on a ring. Or there is a hole where you can insert the wire and then tighten it. There are 3 connectors. Black is a minus, red is a plus. Green is a connection to the device body. At the top is voltage control. This is current control. We'll talk about the rest a little later. Pay attention to the modern design of this device. There are cooling holes on the case. The power cord is connected to the back. Just below is a fuse that needs to be changed if the device does not work. And a fan that turns on when the temperature inside the device is more than 50 degrees, so that the power supply does not overheat. Here are the instructions in English. I think after this video, you won't need these instructions. The fuse is removed in this way. Here is the fuse itself. And there is a spare fuse in case the main one burns out. So I put it in place. Let's look at the controls. Above the terminals there are 2 buttons. One is to turn on the power. I have already pressed it. The second button is to supply power to the output. In the middle there is a USB output for 2 amps 5 volts. Just above are 2 LEDs. CV lights up when the power supply is in voltage generation mode. CC lights up when the power supply is in current generation mode. When turned on for the first time, no voltage is supplied to the output, and the lower indicator shows off. The preset voltage is indicated at the top, and the preset maximum current is indicated in the middle. These values can be adjusted. To adjust the voltage, press the knob. And we can adjust the output voltage. Please note that first the adjustment begins in the least significant digit. And if we need to set a lot of voltage, it will take a long time. Therefore, we can press the knob again, and we can adjust by tenths of a volt. Here I am adjusting. If we press the knob again, we can adjust it in volts. And we adjust the voltage faster. We can also adjust the maximum current. Click. Here we regulate with an accuracy of hundredths of an ampere. If we press a button, we can adjust the amps. This control is very close to digital control, where each digit can be adjusted separately. Initially, you need to get used to this adjustment. But I think it's better than analog control, where there are two separate knobs, rough and fine. This is usually done with variable resistors, which, as they wear out, become difficult to set the required voltage or current value. After the preliminary settings, we can apply voltage to the connected device. Once connected, we can also adjust the output voltage. If the current is higher than we set, the power supply will switch to current-based power mode. And this LED will light up. The devices will show real voltage values, circuit current and load power consumption. So I connected the load, these two light bulbs. These are 20 watt and 12 volt light bulbs connected in series. That is, together they can be connected to 24 volts. At the same time, they will consume 40 watts. To apply voltage, press the key. This key lights up green, and we can adjust the voltage. We will regulate exactly units of volts. And so we raise the tension. 3 volts. And we see the light bulbs light up. We show the current in the light bulbs and the power consumption. So we supplied 24 volts, and these lamps consume 38 watts. Let's lower the voltage so that the lamps don't get too hot, let's say down to 12 volts. As you can see, we have a current of 1.120 amperes. Let's limit this current to 1 ampere. Turn off the load. We regulate. Turn it on. As you can see, our power supply has switched to current generation mode. We have a current of 1 ampere, and at the same time the voltage has decreased to 9.4 volts. We can try to increase the voltage, but the power supply still limits the current to 1 ampere. We can also raise or lower the current during operation. Here we will regulate tenths of an ampere. We lift it up and see how the light bulbs begin to burn brighter. We lower it, and the power supply is still in current generation mode. Regular viewers of the channel remember these clamp-on multimeters. In the video, I doubted that they were giving the correct DC readings. And this turned out to be true, the DC readings were indeed off. I calibrated them using this power supply. How to do this is described in a video by another author. I left a link to the video in the description. I set it to 10 amperes. I close the output of the power supply and turn on the power supply. I have 10 amps in the wire. As you can see, the clamp meter also shows around 10 amperes. So the technique from the video works. This is a device that will be useful in any home. If you have any questions, ask them in the comments. You can also ask them to the manufacturer. A link to the manufacturer's page with this power supply is in the description. Share the video with those who might find this device useful. Subscribe to the channel, like and see you in new and old videos.